Now let's write the operational semantics of KFAE in the style of small step operational semantics. As we discussed already, we introduced one language construct to introduce first class continuation. When we interpret this expression, we may use the name x, and the value of x is not visible syntactically in this language construct, but the value of x is the work to do after evaluating this expression. That's the value of x. Then we extended the value to have one more kind of value, cont v. In addition to number and closure, we added cont, which represents continuation, work to do. Getting a value and then producing another value. So in the operational semantics as well, we need to extend the value v to have three kinds. In addition to number and closure, we added cont v. And this continuation is now a pair of cont k and stack s. So the cont k is k that we discussed before. Stack s is s that we discussed before. So value is now extended with continuation, which is a pair of cont k and stack s. Then we already discussed that two kinds of language constructs to discuss to implement continuation are function call, app, case, and VCC. This is the introduction, this is the use case. And when we have E1, E2, depending on the value of E1, it could be closure V or cont V. So when we interpret E1, E2, when that's the first thing to do in the continuation, then we split now to interpret E1 first, interpret E2 next, and then function call itself. Then because this is the top, meaning this is the first thing to do, we interpret this E1. That could be num-v or closure v or cont v. If it's number, it's an error. We do not have a rule for that. If it's a closure v, that's gonna be this case. If that's cont v, that's gonna be this case. If it's closure v, when we interpreted E1, get the value closure v, pop it, and push the value onto the stack, and we evaluate E2 next, get the value v, pop it, push the value into the stack, and get to this function call case, then on the stack, we are going to have closure v and argument v. Closure v and argument v. Then what we are supposed to do is to interpret the body E under this usual environment. That's the usual case. What about cont case? Cont case, we said that this cont v captures continuation, which is a pair of k prime and s prime. Then we forget k and s, the continuation that we constructed so far. Just, don't go back to that k and s. Just call k, new k with the argument. How can you represent that? When we interpret E1, E2, we split it E1, E2, and then call case. When we interpreted E1, that was k prime, s prime, cont v. When we interpret E2, that was some value v, right? And then we get to this top level alpha. Then pop it, and we are going to apply this new continuation kv to this new argument av, right? So what's that? Get rid of old k and s, replace old k with this captured k prime, replace this old s with captured s prime using this value. Do you see that? This is the place to forget the past, burn the bridge, move on to the new life. That's the semantics. How about constructing continuation? VCC was that, right? VCC x e. The value of x is continuation, which receives a value, and using the value, do the next work to do after evaluating this expression. Meaning that when we interpret E, when we interpret B, we may encounter X. So we need to extend this environment with the value of X, whose value is the work to do, which is this K. When we are done evaluating this body expression, the remaining work to do is also K. How can you represent this as the operation semantics? This. Under a given value stack and this cont with this expression to evaluate, this continuation creation under this environment. Then what's gonna happen next? Value stack doesn't change, and the continuation stack says that we are going to evaluate this expression. We are going to evaluate that expression. Under which environment? We extend the environment for this name x. What's the value of x? Cont v, meaning k and s. So we captured the current work to do and the value stack as a continuation. Remember that, and remember when we call that like this, we just jumped to that point. We just jumped to stored continuation. Okay? If it's not yet clear, this is an example for you. I'm not gonna go over this step because it's your exercise. Interpret the expression this. Oh, what is that? 1 plus this one. What is that? It's a continuation introduction here. X's value is a continuation, which he is supposed to do what? Get the value and add the value to 1. That's X's continuation. And using that, we interpret this one. And you should be able to understand these steps, and you should be able to write it down. Okay? So, in the beginning of Monday's lecture, we discussed control statements, those control statements in imperative programming languages, like return statement and break and continue statements in while loops. So, in a function expression or function definition, one can return in the middle of function definition or function expression using a value, and we can simulate that by using continuation in this way. Like when you want to return, then remember this point, and that's gonna be the continuation return, and then interpret this evaluation. And while you are interpreting this evaluation, if you encounter return with some value, then you don't need to do all the remaining work and just come to here. Escape to the end of this function definition or function expression and be done with it. How about break and continue? So we can rewrite this while condition E1 and body E2 like this. Continue is to go back to this point, right? Like this point. And break is want to go back to this point, right? So what can we say? We are gonna enclose this while expression with this continuation introduction saying break, break, and then while. Then what means that while you're evaluating E2, if you encounter break, you're going to go back to here. And while you're evaluating E2, if you encounter continue, then you're going to go back to here. That's it. Okay, as usual, we have articles about first class continuations, and you have project number 2, which is available from Piazza 2. Project number 2 is especially designed for continuations, because continuations, that concept is one of the most not obvious feature for most of the students, because most students didn't experience this cool feature. So project number 2 is going to help you understand this concept better. Okay, thank you.